All right, this is the video for Friday, February 12th. Today's bell ringer: explain what causes a change in quantity demanded, and explain how a change in price affects the demand for a product substitute. So pause the video so you can answer those questions, and then we will move along. All right, so what causes a change in quantity demanded? Well, a change in quantity demanded is caused only by a change in price. Remember, that was moving along the curve. In order to have a change in quantity demanded, you must change the price. And then explain how a change in the price, affects, the demand for a product substitute. Well, as the price of an item goes up, the demand for that product's substitute goes up as well. As the price of an item goes down, the demand for that product's substitute goes down as well. So think if we sell Coca-Cola and our substitute is Pepsi, if the price for Pepsi goes up, our demand for Coca-Cola goes up because people are going to go buy Coca-Cola instead of Pepsi because Pepsi is more expensive. Same thing works, but in reverse. If Pepsi goes on sale, our demand would go down because people are going to buy Pepsi instead of Coke because it's on sale and they see it as a substitute. So in your notebook, name a product that has a high variance in demand when prices change. Name another product that does not. There's a lot of things these are sort of the things we talked about yesterday in class about how maybe the law of demand might not necessarily apply as much. And so you're going to be looking for things that might fit in there. So pause the video if you need to do that. I'm not going to go over them. You need to use your own brain for these. All right, elasticity of demand. So elasticity is a measure of responsiveness that tells us how dependent variables such as quantity responds to a change in an independent variable such as price. In other words, how much is this change going to be, how much is the law of demand going to apply to this item? Okay, it's a measure of that, right? You could have something that it's very elastic or very inelastic, and it's going to be based on how much the dependent variable such as quantity, so how much that x-axis changes based on the independent variable that's price. So is it going to be a very flat line or a very vertical line based on the elasticity? So how much is the change going to be? And then demand elasticity is a change in prices cause a change in quantity demanded. You know that, okay? This is just another way to state the law of demand. In that when you change prices, you're going to have a corresponding and actually reverse change in demand. Prices go up, quantity demanded goes down. Prices go down, quantity demanded goes up. Now, elastic is in a given change in price causes a relatively larger change in quantity demanded. So this is going to be, for example, and you can write the example in your next box. For example, the demand for vegetables are higher in the summer because the prices are cheaper as opposed to the winter where prices are higher and demand is lower. So that is going to be an example of an elastic demand. And that's going to be just having like a really big change. Okay, so if you think about it, something that if the price goes up just a little bit, then the demand is going to go down a whole lot. Or if the price goes down just a little bit, the demand is going to change by a whole lot, right? So these are things that have a very high variance in demand. Inelastic demand, on the other hand, is a given change in price causes a relatively smaller change in quantity demanded. Inelastic product like table salt, and you can write that as an example in the box below it. Products like table salt do not see much of a change in the quantity purchased based on their price. If the price was cut in half, the quantity demanded would not increase by much. So this would be something like, just because the price goes down, you're not stocking up on this thing. And you're not stocking up on this thing because you don't need more of it because the price went down. And maybe there's also issues about saving it just because the price went down. So if there's a sale on an item and you say, nope, I'm not buying more of that, well, that might be because it has a very inelastic demand. these are the things where there's very little change in the quantity demanded based on the price. So that's going to be inelastic demand. And then last thing is the unit elastic demand. And this is some products or services fall midway between elastic and inelastic. This means that a given change in price causes proportional change in quantity demanded. So for example, a 5% drop in price would cause a 5% increase in quantity demanded. These might be a little difficult to visualize until we see them in graph form, which is why we've been graphing demand this whole time, is so that you can easily understand elastic, inelastic, and unit elastic. Unit elastic is mostly going to be a theoretical concept. We're not actually going to have perfectly proportional unit elastic things. It's going to be some measure of elastic or inelastic, but for practical purposes, you can think of unit elastic as being sort of in the middle, right? Sort of close to the middle here. So we're going to use the total expenditures test. Now, before I get to the total expenditures test, I want you to look at the visual representation of elastic, inelastic, and unit elastic here. So in our elastic demand, notice that the price is $3. We lower the price to $2, and all of a sudden we get twice as many people buying it. So we have a very shallow line on this elastic demand. It's going to be very shallow here. The inelastic demand is going to be a very steep line, where lowering it from 3 to 2, from A to B, we lower the price from 3 to 2, we only increase the people who want it from 2 to 2.5. And then the unit elastic at $3, 2 people want it, and then at $2, 3 people want it. We go down by 1 in price, we go up by 1 in quantity demanded. So that's going to be a nice little visual representation of elastic demand, inelastic demand, and unit elastic demand. But we also want to be able to use the total expenditures test. This is the amount that consumers spend on a product at a particular time. So the total expenditures test is found by multiplying the price of a product by the quantity demanded for any point along the demand curve. What does that mean? Well, basically, we are going to take A here, and we're going to multiply price times quantity. 3 times 2 equals 6. So we are going to have a profit. We're going to have revenue of 6. Okay? If we sell 3 things at $2 a piece, we make 6. We have $6. Now, over here, if we sell for $2 each, we're going to sell 4 things. We're actually going to have 2 times 4 is 8. So our revenue at point A is 6, and our revenue at point B is 8, because we're selling 3 things, or sorry, at $3 we sell 2 things, so we have $6, and at $2 we sell 8 things. That means, sorry, at $2 we sell 4 things. That means we have $8. Okay, that's going to be our total expenditures test. Now, if here in your notes, so this is where it gets a little complicated, so you need to stick with me. Our total revenues test is TR equals P times Q. Total revenue equals price times quantity. That's what I did back on this slide when I did the total revenue, which is price times quantity. $3 times 2 sold is our total revenue at point A is $6. Total revenue equals price times quantity. Now, if price and total revenue move in the same direction, demand is inelastic. So I'm going to come back to this, but let me show you what that means. If they move in the same direction, demand is inelastic. So here's our example of our inelastic demand. If price and total revenue move in the same direction, demand is inelastic. So from A to B, price is moving down. Okay, it moves from $3 to $2. That means if total revenue A to total revenue B moves down as well, demand is inelastic. So total revenue at point A is 3 times 2 is going to be 6, and then total revenue at point B is going to be 2 times 2.5, which is 5. So as price moves down from A to B, total revenue moves down from 6 to 5. Therefore, it is inelastic demand. We can do the opposite direction as well. From B to A, price moves up, and at point B, our total revenue, if we sell 2 of them, if we sell 2.5 of them at $2 a piece, then we make $5. And if we sell them at $3 a piece, we sell 2 of them, so that's 6. So if we move from B to A, we're moving up. Demand is increasing, and our revenues are increasing as well. That means that it's inelastic demand. You can probably guess that if price and total revenue move in the same direction, demand is inelastic. That means that if price and total revenue move in the opposite direction, demand must be elastic. So here's what that means now. If we go back, look at our elastic chart. From point A is 6. In fact, point A is 6 on all these charts. From point A at 6 into point B at 8, remember, because $2 times 4 sold. From point A to point B, you are moving down in price, but you are moving up in revenue. Okay, from $3 to $2, you're moving down in price, but you're moving up in revenue from $6 to $8. That means that price and total revenue are moving in the opposite direction, and therefore your demand is elastic. Last one, if total revenue remains the same when price changes, demand is unit elastic. So this is this straight line sort of thing. From A to B, we have a $1 drop in price, $1 drop in price, and then $6 at A and $6 at B, because it's the same all the way along this line. And if we kept going, it would continue to be the same. We would find that our demand is unit elastic. Okay, so those are the things there. I'm going to give you a couple examples. I want you to pause the video so that you can answer these on your own. All right, yesterday the price of envelopes was $3 a box, and Julie was willing to buy 10 boxes. Today the price has gone up to $3.75 a box, and Julie is now willing to buy 8 boxes. Is Julie's demand for envelopes elastic or inelastic? So what you're going to do is you are going to take your $3 and you're going to multiply it by 10 boxes, and you're going to realize that Julie is willing to spend $30 at the beginning in order to buy those boxes. Now, if the price goes up to $3.75 a box, you're going to see that Julie's only willing to buy 8 boxes. And that makes sense because that would be the law of demand, right? So here we're gonna do it here. We're gonna go 8 times 3.75 equals 30. Okay, so Julie is willing to still spend $30. So what does that mean? If she's willing to spend $30 in either case, because the amount that she's willing to spend does not change, we have unit elastic. Remember, that goes back here. If total revenue remains the same when price changes, demand is unit elastic. So on Julie, we change the price. We don't change the total revenue. Total revenue remains the same. Therefore, it's unit elastic. Okay, let's try another one. Catherine advertises to sell cookies for $4 a dozen. She sells 50 dozen and decides that she can charge more. She raises that price to $6 a dozen and sells 40 dozen. Is demand for her cookies elastic or inelastic? Right. So we need to do the total revenues test. $4 a dozen times 50 dozen. Now, you could go ahead and find out what 50 dozen is and multiply 50 times 12 times 4, but I'm just going to multiply 4 times 50 and get 200. I'm going to say 200 dozen. And then I'm going to say 6 times 40 dozen is going to be 240 dozen. So in which case does she have more total revenue? Well, we're going to have 4 times 50 is 200, and 6 times 40 is 240. Now, if you remember back here, if price and total revenue move in the same direction, demand is inelastic. And if they move in opposite direction, it is elastic. So as she raises her price from $4 to $6, she raises her total revenue from 200 to 240. Therefore, it is inelastic because price went up, revenue went up, And we know that when price and revenue move the same direction, which in this case is up, demand is inelastic. Next one. Nope, I guess that's it. So there's another way to just sort of figure out if things are elastic or inelastic, and that is with estimates. You're not always going to have the numbers. You're going to have to sometimes decide whether something is going to be inelastic before you know your sales, right? You can't just say, she could say, Catherine, on our last example here, she could say, I think that if I raise my prices to $6 a dozen, I'll sell 40 dozen. But before she does that, she doesn't know how many dozen she's going to sell if she raises her prices. So she's going to have to use sort of this chart to help her determine what the result is going to be. So if in this, if the answer to the question is yes, it's going to indicate elastic demand. And if the answer is no, it's going to indicate inelastic. And if you remember, elastic demand, a small change in price causes a big change in the total revenue. So if you think about what elastic does, elastic, like on your waistband, allows it to stretch, or like the elastic clause in the Constitution allows the Congress to stretch their powers. So if we're remembering elastic, remember that it allows it to be stretched, that a small change in price allows a big swing, a big stretch in the amount sold. So if the answer to these questions is yes, then it indicates generally that it's probably going to be elastic. If the answer is no, then it's probably going to be inelastic. So if can the purchase be delayed? If the answer is yes, the purchase can be delayed, it usually means that it's going to be elastic, that changing the cost will cause people to delay their purchase if they have to. Are adequate substitutes available? Again, if the answer is yes, it's going to be inelastic, or it's going to be elastic. And if the answer is no, it's going to be inelastic. Does the purchase use a large portion of income? If the answer is yes, it's likely to be elastic, right? Because a small change in price for a large portion of your income could actually be a lot of money. And if the answer is no, then it would be inelastic. And so we're going to use these three questions in order to answer what are these things. So for fresh tomatoes, corn, or green beans, can the purchase be delayed? If the answer is yes, then it's likely to be elastic in that case. Are adequate substitutes available? If the answer is yes, then it's likely to be elastic. In this case, it does not constitute a large portion of the income. So in that case, it might be inelastic, but we have 2 out of 3 here. It's going to be elastic. Table salts. No, the purchase can't be delayed. When you're out of table salt, you're out of table salt. Are adequate substitutes available? There's not really a substitute for table salt, so no. And does it constitute a large portion of your income? No. Therefore, if the price of table salt goes up, you're still probably going to buy it. And if the price goes down, you're not going to stock up on it, right? Gasoline from a particular station, can the purchase be delayed? Yes, it can, right? You can go across the street to the other station. But let's compare that to gasoline in general. Can the purchase of gas be delayed? Well, if you're running on E, you're running on E. You might as well get gas. Okay. Are adequate substitutes available? Substitutes to gas from a particular station? Yes. You can go to any other station. Gas in general? Nope. Your car's low. You got to get gas. Does it constitute a large portion of your income? Well, it depends on what your income is. So the chart says yes. I might say no. It depends on what your income is. So gasoline from a particular station is elastic. You have all kinds of choices in case gas prices go up for you. But gasoline in general, the answer would be no. It is inelastic. Service from medical doctors, no. Purchase can't be delayed, hopefully, or I guess generally. Are adequate substitutes available? No. Does it constitute a large portion of income? Less, yes. So it's going to be inelastic. Insulin, no, it can't be delayed. No, there's not adequate substitutes. No, it doesn't constitute a large portion of your income. So if the price goes up, we still have the same number of people who want it, right? So why don't you look at some of these things? Use your 3 questions. Can the purchase be delayed? Are adequate substitutes available? Does the purchase use a large portion of your income? Go ahead and pause the video so that you can answer these questions. All right, Eggo waffles. Are Eggo waffles going to be elastic or inelastic? Generally speaking, they are going to be elastic. The purchase can be delayed. You don't need Eggo waffles right now. Are adequate substitutes available? Yeah, you could get the store brand, or you could get, I'm sure there's other brands. Does it constitute a large portion of your income? No, but we have the other two answers that are yes, and so that's going to be yes. An oil change. What do you think? Is an oil change going to be elastic or inelastic? It's going to be elastic. Can it be delayed? It actually can be delayed, right? If you've been driving 6,000 miles on your tank, then probably it can't be delayed that long. But you know what? You can probably, once you get to that point, you can keep driving it for a little while. Are adequate substitutes available? There it is, because you can go to any kind of different station. You can do it yourself, so it's going to be elastic in that way. And does it constitute a large portion of your income? Not really. We're looking at $50 every 4,000 or 5,000 miles, depending on your car. Okay, so in that case, oil change is elastic. Kidney transplants. This is going to be the easiest one. Can it be delayed? Adequate substitutes available? Does it use a large portion of your income? The answer to all those questions is no. So therefore, it is inelastic. If you need a kidney transplant, you're going to get a kidney transplant. That's it. You can't. There's no other substitutes. There's no options. There's no, I'm going to wait for the price to go down. If you can't wait for the price to go down, then it is inelastic. Electricity. Electricity is inelastic. You can't really delay the purchase of electricity, right? If it's a hot day, you can't be like, don't worry, I'll just wait to run my air conditioning tomorrow, okay? The bill comes when the bill comes, so you can't delay it. There's not adequate substitutes available. I guess you can go jump in the pool if it's too hot, but if you don't have a pool, there's no adequate substitutes available. What about ground beef? Ground beef is elastic, and ground beef is elastic because you can do ground turkey or ground chicken or any kind of other food if ground beef is really expensive. College textbooks. This is going to be the most interesting one. What do you guys think? Can it be delayed? Are adequate substitutes available? Or does the purchase constitute a large portion of your income? We're going to say inelastic because you can't delay it for too long because the semester is starting, and you can't just get an adequate substitute. You need the textbook that your college professor offers, tells you that you need, and it's also pretty expensive. So it's going to be inelastic. You might argue that it's elastic because half the time the college professors put those textbooks on the list. You don't actually need them, but you can figure that out once you get to college. I can tell you that I spent a lot of money on textbooks that I never ended up using, but professors thought it was super important that I spend all that money. So figure that out once you get to college. Next, we're looking at a couple of extreme cases. We're looking at perfectly inelastic demand. Consumers will purchase the same quantity of goods or services regardless of the price. This is going to be represented by a vertical line. No matter what the price changes, it doesn't matter. People are still buying the same amount exactly. Examples: insulin, antivenin. So insulin is a good example because if the price goes up, if the price of insulin doubles, triples, or goes 10x, it doesn't really matter. Diabetics still are going to buy insulin. And if the price craters and it's almost free, well, I'm not a diabetic, I'm not going to buy insulin, right? So the quantity demanded doesn't change, but no matter what the price is. Antivenin is the same way. You get bit by a snake, it doesn't matter what the price of antivenin is. You're not going to argue about the price when you get to the clinic, and you're not going to be stocking up on antivenin if you've not been bit by a snake, right? So those are perfectly inelastic demands, are characterized by a line. Now, if I guess you could say that at some point the line sort of tapers off and kind of goes up in this way, and that might be if you say, well, I know that, Mr. Thor, I know that you say that insulin is super expensive, or is, what if they raise the price? You're still going to get it if you're diabetic, right? Well, what if they raise the price to the $10 million a bottle? Well, I don't have $10 million a bottle. So yes, there becomes a point where I just can't purchase it. And at that point, maybe it does taper off. But for the most part, we're going, and that's sort of the purpose of government in some of these things, is to control some of those prices. But for the most part, it's going to have a straight up demand line just like that. Next, we have perfectly elastic demand. So this is when consumers will purchase infinitely more or less of a good or service at any price change. So you change it at all, and it changes entirely. So it's going to be a horizontal line. So can you think of any examples of that? Well, there's actually no true examples of inelastic demand, but sort of examples, close examples are luxury goods, Black Friday, things like that, where if people are going to buy it no matter what price you put it at, right? Does it really matter if that Birkin bag is $10,000 or $15,000 or $200,000? It really doesn't matter. You're still going to have the same clientele of people buying it, right? And then Black Friday is that once there's a sale, people aren't probably thinking about how much money they're saving when they do these Black Friday sales. This is a COVID nightmare right here. But they're probably not thinking about how much they're actually saving, but they know that there's going to be big savings, and so they pack into the stores to buy those things. So that would be sort of an example, but there's no real true examples of a perfectly elastic demand.